In this video, we will move on to section 7.3, which is on rules of differentiation involving functions of different variables. This means, for example, we have the function z is a function of y, and we have y is a function of g of x. The first rule is the chain rule. This is where we want the derivative d of x with regard to x, and then we want, so we know x of z is a function of y multiplied by the function y with regards to x. As you see, these will cancel out in effect. They cancel and we are left with the z dx, but we don't know what the z with regards to x is just from our function. What is important to note here is if it's with regard to x, that means dx, we only want x in the answer, not y. Okay. So we have our change in x, which changes y, that changes z. The change in x to the change in y happens via the function g. The change in y to the change in z happens via the function of f. So if we do two examples of the chain rule, say we have the function z is equal to 6y squared plus 2y plus 4, and we have y is equal to 4x squared plus 2. We want the derivative of z with regards to x. This will be dz with regards to y times dy dx as per our chain rule. dz dy is the derivative of this function, which is 12y plus 2, times dy dx, so the derivative of y with regards to x, which is 8x. As you can see, we now still have this y in our answer, but we know that y is equal to 4x squared plus 2. So we simply replace y with 4x squared plus 2. And then we simplify. 12 times 4x squared, 48x squared plus 24. Everything multiplied by 8x. This is equal to 384x cubed plus 192x. How is this important economically? For example, if we have our revenue is a function of the quantity that we sell, we know this is price times quantity, but our quantity is manufactured by labor. For example, L to the power of alpha. How do we know how our revenue changes with labor? This will be the derivative of the revenue function with regards to labor. This is equal to the derivative of revenue with regards to quantity times the derivative with regard of quantity with regards to labor. The derivative dr dq is q times p to the power of q0 times alpha L alpha minus 1. Q to the power of 0 is simply 1, So we are left with P alpha L alpha minus 1. The second rule with regards to different functions is the inverse function rule. If we know that y is a function of f of x, we know that x is the inverse function denoted by f to the power minus 1 of y. If we know these two to be true, we know that the function is strictly monotone, which means on the Cartesian plane there is 1-to-1 mapping. If x of 1 is, or x1 is larger than x2, and f of x1 is larger than f of x2, this is a strictly increasing function. If x1 is larger than x2, but f of x1 is smaller than f of x2, this is a strictly decreasing function. How does the inverse function rule of the derivation work? So we have y equal to 6x plus 36. So solve for x first. So that is y minus 36 will be equal to 6x. That means 1 over 6y minus 6 is equal to x. That means the derivative dx dy is 1 over 6. The derivative dy dx is equal to 6. That means our inverse function dx, the derivative of the inverse function dx dy is equal to dy dx to the power of minus 1. Stated differently, dy dx is equal to 1 over dx dy. You can see it from this example. The x dy is 1 over 6 equal to 6 to the power of minus 1.